Okie dokie. Well, again, just echo Andy and then Joris's opening sentiment. So my name's Patrick. Really delighted that everyone could be here today. I'm Chief Scientist here at Stats Perform. Got a wonderful venue here. Glad that we can show it off. Glad you're having drinks and enjoying the night. So today what I'm going to talk about is just some of the recent work that we've been doing with broadcast tracking and how we can make it complete. At the end of this, we have a bit of code that we can share. So we have a sample game for our imputed tracking data. But basically, I'm just going to step you through the why and the how and go in the detail of this. But ultimately, what we do at Stats Perform, we're the keeper of public record. Basically, what we want to do is provide data and analysis for every game of sport that's been played. We have a deep footprint in football, and we continue that. So really, we want to enable football analysis at scale. So how can we do that? So one thing, and that's what I'm going to talk about during this presentation, is how we can provide complete tracking data at scale. Probably saying, well, what does that mean? I'll talk about that shortly. Also, once we have the raw ingredients there, we can do that full reconstruction, cover every frame with tracking data and the ball information. We can do metrics at scale. That means for every pass, we can give the expected threat, expected receiver, expected pass, all these things so we have no gaps. Then we can measure shape. We can do all this nice stuff. But to do complete analysis, you need complete data. But another thing is to actually provide tools to utilize everyone here, the data and metrics. So this field is mature now. I've worked in this space for 15 years, Jan and others, it's similar. The amount of time that you have someone new starting, especially with tracking data, and they have to create their own visualizer. It's really annoying. So we want to reduce the barrier of entry, and this is a starting point for us. It's great that we partner here with PySport, but for us at Stats Perform, we want to provide these tools for everyone to utilize. There should be no barrier to entry in using our data or the metrics, because these metrics, you shouldn't have to create them. You should utilize them, because each club or whatever you do, you have your own IP. You have specific questions that you need to answer. We just want to be the platform or the foundation that you can do all the unique stuff for your organisation. So what I'm going to talk about now is some work that we have done recently. It's really been 2.5 years. So it'd be great if Harry was here. He's a PhD student working with us. He's done some amazing work. I've actually worked with him the last 3 or 4 years, and these are some of the fruits of that great work. This has been a big undertaking, but we're really excited with where we're going with this work and excited to show it off today. And I'm going to go in more detail tomorrow about this as well. But ultimately, at a high level, as I mentioned, to do analysis in football, you need complete data. And so what do I mean by that? Well, you have event data, which tells us the how. And at Opta, we're the best at collecting that. We have detailed data. We do that live and at scale. Okay? But then you have tracking data, which tells us where the players are in the motion and how they move. And essentially what we want to do is have that for every game that's been played. Okay, so just to kind of give you a quick history, is anyone here under the age of 25? Okay, tracking data is older than you in football, okay? It is actually a MISCO, and Jens can tell you war stories with a MISCO and Prozone. Started doing that in 1998. Okay, there's an excellent athletic article written last year, goes through the history of that. Started with Derby County and then Manchester United. But essentially, we had humans doing that. Then we purchased SportView in 2008. Then we started to do automatic data collection. Used widely by sports scientists, actually get how far players ran, that different segmentation. And so this is kind of where we're at. But then that doesn't scale, as I mentioned. So we can use broadcast tracking. And broadcast tracking, seen as a holy grail, I've focused on this the last 5 years or so. We've done this in basketball. And the last 3 or 4 or 5 years, we're doing this in soccer. Now, the nice thing with broadcast tracking is that it's scalable, meaning that every game where we have video, we should be able to just digitize that. And what I mean by digitize that is actually capture the positions and velocity and accelerations of all the players. The problem here, as we all know, is that there are players missing, okay? There are players out of screen, but a bigger problem, and I'll highlight it here on the left, is that to do broadcast tracking, you need the main camera. And this is an extreme example. This is from the Bundesliga, and 80% of the in-play was actually just from this main camera. 20% was from the close-up. Play was actually happening, a lot of action, a lot of passes were occurring, but we actually weren't capturing that via broadcast tracking. okay? So this is a problem. As we know, football is low scoring. We have shots, and often that comes after a mistake or a quick counter-attack. We need to capture that, and that happens often when we go in between these views. Now, again, this is an extreme example, but even if you half that, the amount of data that you're missing is extreme. Okay, so we've worked on this the last couple of years. We want to provide complete data. So we want to have the same amount of data that you have from in-venue, even if we have to estimate that. So that's really what we've done. So I'm going to show an example here, and we're going to give a sample game. I'll show you where we have that on a repo later, but let's just play this example. Okay, so here it's just passing around the back, and so here they'll do a close-up for about 9 seconds. So in this 9 seconds, we will miss 3 passes, okay? We don't have broadcast tracking, but our method here, I'll move my big head, we're actually able to estimate that, okay? Now the secret sauce is actually the event data, okay? The event data gives us the backbone of knowledge. So I'll just play that again. So you can see here, so when it goes through the back, they'll do a close-up. Our operations team are able to estimate who's passing and where. They're able to do that visual transformation, and with that context, and given what's happened before and afterwards, we can tell this full picture. Now, data collection, event data is complex. It's not easy. You can't get anyone to just do it. You know, operations team have expertise. We talk about mastery. Sport is all about mastery. You need to understand it. I was talking before about the perception. You need to understand what these things are. Especially with video, we don't get to see the digits on players. We don't get to see those actions. Our brain is able to fill in these gaps. So essentially what we're doing here is using the human vision system and the computer vision system together, multimodal, 2 modes, and we're able to reconstruct that full picture there. Okay, and so the way that we do this is using these generative techniques. So you've probably heard of ChatGPT or DALL-E 2 or DALL-E 3, where they use diffusion. So the idea here around diffusion is basically to use these diffusion networks, and they're able to gradually hone fine-grained details. So in images, you have lighting conditions, shadows, and object edges. In sports, especially around trajectories, we have these motion vectors, okay? And so what we're able to do is use these diffusion networks to reconstruct what we would see, but given initial inputs from event and the broadcast tracking. And so that tends to work really, really well. So there's some work being done using transformer networks. They work well, but they don't provide smooth, realistic trajectories. You get a bit of jitter here. Here you get realistic looking trajectories. And so from this, so we have a paper that's going to go on archive very, very soon, within the week. And so we've done all these comparisons against different networks. The key thing to highlight here is that a lot of the work that you see, so competitors will do that short-term occlusion, STO, but they really won't focus on the long-term occlusion. So wingers could be out of view for 2 minutes, 3 minutes. We focus on that, okay? And this method works really, really well. And really the value here is actually addressing the long tail, because where these long-term occlusions will exist is really at the lower tier leagues, okay, where they don't have the great video, good vantage point. And that's really where we see this fusion between the event data and broadcast tracking working really well. And so here we have tracking data from our sport view system. This is from the French League, Clermont Foot, playing PSG. Here we have the ground truth data, meaning the sport view data. Here we have our broadcast tracking data, and here we have the event data. Key thing to notice is that in this example, we actually don't have the ball. We're able to generate that ball, okay, realistically. We're able to make that look realistically based on the event, because the ball is an inanimate object. It needs an action to actually move it, okay? So we're able to ground it to real world and able to actually do this really, really nice reconstruction. So we're currently at early access. So this is still work. We're very happy. We think we've cracked this very difficult problem, but we're just doing some fine tuning now. And so what's nice about this is that we can actually analyze every pass, okay? Not just most passes in the game. Our goal is to analyze every pass, okay? When you're making decisions, that's important. You don't want to have any gaps. And we're able to do this via, this method. And so you've probably heard a lot, A lot of people in this room have done a lot of great work in this space, but here we can actually do this for every pass. So expected receiver, expected threat, expected pass, and you can do actually more because you actually have the raw ingredients. You don't have to work in this aggregated space. And you can focus on situations when you have close-ups. And so as we progress, so what we're actually releasing today is a visualizer linked with events. You can click through, you can scroll through, but as we progress, we actually want to make available all these visualizers, all these metrics as well, whether it's these passing outputs or whether it is shape or anything downstream. So this is just a start for us, but we're very excited with where we're taking this. So as I mentioned, the model can improve still. A couple of examples here. So we have Mo Salah. So the current model will actually just give an average position, especially when a player is out of view for a long period of time. But when you have a specific nuance, just say Mo Salah is played more as an inverted winger, our current prediction, if you don't see that player, will basically place him kind of slightly more out. Or compared to Jack Grealish here, when he's really on the sideline here, he'll be tucked in, especially if we don't have an observation for a long period of time. So where we're going with this is actually fine-tuning. An analogy would be with ChatGPT, when they're fine-tuning based on human feedback. So that's really where we're at, but we can personalize based on the team and characteristic of the player. Also, we need to utilize more of the event data, especially around shots. So our event data is so detailed, we capture so much, and we do that live, so we can actually embed that more. Currently in the model, we don't utilize all that rich event data, and that's what we're looking to do. So big thing about this is actually code, okay? So it's great, we can showcase all this stuff, but really for practitioners here, we want to make available code. So we have this repo, Harry's put this on his repo, and then I'll actually pull up the code and show you how that actually works. So essentially what we have here, if you go to the repo here, you'll just have the requirements. So you can just create your virtual environment, use Python 3, I think it's 3.10.12. Once you have that, you can have your virtual environment, then you can install all the packages required. Then ideally what we wanted to do, we were trying to do this last couple of years, or Thomas, when you worked with us, it's ages ago. We actually wanted Google Colab. Google Colab is amazing because it's just Google Docs, but for machine learning. You just want to share a link. Unfortunately, with visualizers, especially with tracking data, have been able to figure that out. That'd be great. Someone in this audience or this community could help us solve that because that would help everyone, okay? But here we don't have that. So we have these extensions like QGrid and these widgets, and that really helps us kind of with this interaction. So I'll just run this code here. So I pre-ran it, so I didn't have complete egg on my face. So what we've also done is provided a game. So just have a Dropbox link here. It's just in a Parquet file. So we just have that URL. And so we can just download that, then we read that into Pandas via this PD read Parquet, and then you download that. Here we have a description of all the data sources. I'll just run this. And then, really, we just have this animator here, okay? So, let me get a bigger view here. So what's nice here is that you have all the modern controls, so we have, we can scrub through, but here we also have it tied to the event data. So essentially this is a player where you can just scrub through to a part of the game that you're interested in, and it'll just take you there, okay? So again, anyone getting started or just having a common visualizer for everyone, we feel is a great step in the right direction. So as we progress, what we actually want to do is have all our metrics embedded here. So if you have a game of Optivision that we have here, you can visualize it, you can scrub through. We can have all our pass outputs embedded in the visualizer here too. We have some initial ones, but it's not ready to share. We can have the shape outputs. Again, we want you using the data and the metrics and then get you doing what you do best. You don't need to recreate the wheel here. So we think this will be a really nice contribution to the community. And again, this field's mature now. You know, we need to start providing this and getting you guys doing what is of most value to you. You don't need to spend time doing this. So I might stop there. Again, it's an absolute delight to have everyone here. We have some great talks. We have Andy talking after the break and also with Peter. Hopefully this is a nice icebreaker. This is just the start of a couple of great days. We have the forum tomorrow. That'll be a great event. We've got a lot of great speakers there. And as I mentioned, hopefully this is a great icebreaker that tonight can lead to more conversations and more conversations after that. So I might stop there. Happy to answer any questions. I think we're allowed to have that. Joris, yeah. Kun? Yeah. So also here, we only generate the tracking data where it's in play. So you're probably seeing nothing's happening there. That's that's on purpose, right? So we play stoppage there. We want to go to actually in play. But as I mentioned, I'll stop there. But, thanks for your time and thanks for listening and enjoy the drinks and the food. Yeah.